this is my 8-bit computer, and it's actually not quite finished yet. My main issue that I'm running into is programming these EEPROMs. I was trying to program them with an Arduino, but I'm having some troubles. So once I get that finished, it'll be like completely done. So the main, or I guess I'll just kind of explain the different components that are going on here. So over here, this, like, each breadboard is like its own little module, you could say. So I have, this is the clock module that actually produces the clock pulses that run the rest of the computer. So you can see it's actually changing now. So I'll explain like all of the little controls. So I have this switch which will it toggles between the automatic clock pulse and a manual clock pulse, and then this potentiometer controls the speed. Yeah, so that's the clock module. And then here I have the program counter, which counts the different steps of a program. So like, let's say a program wants to load something from memory and put it in the A register, and then take another bit of information and put it in the B register. If that's a program, like, the different steps will be represented by, it's just essentially a binary counter. So then next we have this whole section is the RAM. So RAM is actually, it actually stores information in between being powered on and off. So up here is the address for the RAM. So you can see if I actually go to change the address, which is kind of difficult to do. See, now it's at address 16, and you can see in the RAM there's nothing. But if I go to program something, if I want to program this, where the first 3 numbers are like that, and I push the button, it actually programs it in, which is really, it's actually pretty cool, I think, anyway. So do that, and this switch toggles between run mode and program mode. So run mode, it'll actually pull in the address for the memory from the bus over here. So like all of the different modules are connected to the bus. That's how they connect between each other. And then down here, this is the instruction register. Bent LED. So the instruction register actually, an instruction will be stored in memory. The memory will output it to the bus, and then the instruction register will read it in. And then down here in these ROM chips, it'll actually interpret what the instruction does. And when it does that, through all of these wires, it'll actually go over here to the control logic. So each of these stands, or each of these little acronyms, like, stands for something. Like, this is the halt signal, memory in, RAM out, instruction register out, instruction register in, A out, sum out, subtraction mode for the arithmetic logic unit, B in, output register in, clock enable, clock output, and a jump signal. So every time one of these LEDs is illuminated, that means that feature is actually active. So if I want, like, if I stop the clock right now, because I can't program these for some reason, it's just garbage programmed into them. So I have, like, this isn't actually executing any program. I'll have a video later that actually has it executing a program. But like what this is doing right now, what it would be doing is the memory counter in. So this is reading from the bus. The RAM is also outputting to the bus, which that's going to cause errors. That's why nothing's working. So that means that this value is being output to the bus, which is not working. And also the A register is reading in from the bus. So it's going from the bus into the A register. And all a register is just something that temporarily stores a value. And all that value, that value will get erased once power is lost. Also, this is a reset switch for the entire thing. So when I push that, like on the next clock pulse, all of the timer will get reset, all of the registers will get reset if there's anything in them. There's not right now since I've already cleared everything. So yeah. And then over on this side we have the A register and the B register, and what this is right here is the arithmetic logic unit, which what that does is it takes the 8-bit number from the A and B registers and it adds them together, and then it outputs the value on these LEDs. And it can also output that to the bus and put it back in the A register or output it to the output module. Yeah. So, and there's also a subtract feature. So right here, if this LED were illuminated, it would actually be subtracting B from A, and then it would output that here. So that's pretty cool. And this is actually kind of interesting. This is something that I learned about from this project, is pull up and pull down resistors. So I don't remember that at all from DE, but anyway, essentially, like, electricity takes the path of least resistance. So if you have, if normally you have a pull down resistor, the default value essentially will be low because it's pulling it down to ground. But then if for some reason one of these modules is asserting a positive value, so a 1 on one of these bus rails, that's a path of lower resistance, path of least resistance rather, than going through this resistor. So it'll prefer the high instead of the low, and thus like a high value will be represented on the bus, which that's very interesting, I think. And then a little bit of an explanation about the output right here. So it's multiplexing between the different displays. So it can output a 3-digit decimal number, and if the number happens to be negative after being output as a 2's complement from the ALU, a negative sign will show up right here. So that's pretty cool. And the way that's working is it's got a JK flip-flop and a multiplexer right there. And down here, this is a register, which is just like the A register, the B register, instruction register, all of those. So it loads in a value into the register, and while it's being loaded in, it's being displayed over here instead of just on 8 LEDs. So it works basically the same. And the way that it's being converted from a binary number into a decimal display is through the EEPROM, which is an electronically erasable programmable read-only memory, which is a huge acronym. And that is, what it does is it has 11 address lines, and then once you program it correctly, which these are not programmed correctly, 11 address lines and 8 output lines. So once it's programmed correctly, I can address 2 to the 11th different bytes in here. And then every byte has 8 bits, obviously, and the 8 bits correspond to the 7 segments of the display and the decimal point. So these are actually down here the same chip, different of course, but the same model. So it's a 28C16, and they work the exact same way. 8 address lines and or 11 address lines and 8 output lines. But you can see here I'm not using the top 3 address lines on any of these. So these are only using 8 address lines and 8 output lines, which correspond to, one of them is handling the first 8 control signals, and the next one is controlling the other 8 control signals, for a total of 16 control signals. But yeah, so it's a work in progress. I'll give you another video once I have it finished with the ROM chips programmed, once I figure that out. But yeah, thanks for watching.